In this video, we're going to look at an example using variation. Let's look at the premise of the problem. The pitch P of a musical tone varies inversely as its wavelength W. One tone has a pitch of 330 vibrations per second and a wavelength of 3.2 feet. Find the wavelength that has a pitch of 550 vibrations per second. So let's go back and look at and figure out which equation we need to set up. It's either going to be a direct, it's going to be an inverse variation, or some sort of combined variation. We can see that the pitch P is equal to and varies inversely as its wavelength W. So we do P is equal to K divided by W. We know that it's an inverse variation, so therefore we're going to write this inverse variation equation. Now we have our equation set up. We need to find our constant of variation. Here we're going to use our initial conditions where we have 330 vibrations per second and a wavelength of 3.2 feet. So here 330 is equal to K divided by 3.2. To solve for K, I'm going to multiply both sides by 3.2. And I'm going to get 1056 is equal to K. That gives me my constant of variation. So now I can find the wavelength that has a pitch of 550 vibrations per second. So here I'm going to put in 550 as my pitch. That's equal to K, which is my constant of variation. And now I'm going to divide by W. Now this case is a little bit different than other examples you may have seen. The variable that we're solving for is not actually the dependent variable here, it's the independent variable. But that's just fine. We can use a little bit of algebra to help us out. I'm going to bring W up here, and I'm going to bring 550 down here. Using some algebra skills, I'm going to get W is equal to 1056 divided by 550. And that gives me 1.9 feet. And that is the wavelength.